Okay then, so in this video we're going to look at another component which is very, very important in terms of an IV characteristic, which is an LED. Well, an LED looks something like this. If you don't know what an LED looks like, it looks something like this. Now, just to remind you, an LED is a light-emitting diode. First of all, what is a diode? Well, a diode is a component that only allows current to flow in one direction. Current to flow in one direction. So the current is allowed to flow in the direction in which the arrow is pointing. So in this case, the current is flowing from positive to negative in that direction. And that's fine, that would work. However, a diode does not allow does not allow current to flow in the opposite direction. Remember from GCSE, electron flow and current, conventional current, are opposite, okay? A diode is always talking about conventional current. Conventional current is from positive to negative. Electron flow is negative to positive. Now, whenever we talk about diodes and allowing current to flow, diodes allow current to flow in the direction of the arrow in which the arrow is pointing. You need to remember that. Now, diodes have very interesting features that we'll talk about after we've drawn the graph for the IV characteristic. So the IV characteristic for a diode, we'll draw the same graph as before. So we've got our positive currents, our positive voltages, negative currents, negative voltages. So what does the graph look like of this? So it looks a bit like this. Okay, and you'll see variations on that. Now, some of you might be going, oh, does that mean it's the same the other side? Well, no, that's wrong. In fact, there is no line into the negative. Now, this is why drawing a negative-positive graph is so important, because diodes, being a non-ohmic component, non-ohmic resistor, don't have a negative portion of the graph. Why? Well, quite simply because what we've already said, diodes only allow current to flow in one direction. Generally, in this case, the positive direction. So, what we've got here is a situation where we've got the current, we increase the voltage, but this section is very important because that is telling you that up to a certain point, current is not allowed to not being allowed to flow until I reach a very specific voltage across it. We call this the threshold voltage, or the threshold PD. The threshold PD is where essentially what you're saying is electrons have enough energy now that they're able to jump across that diode and actually release energy, and that release of energy usually comes in the form of the light that's being emitted. So when they make that jump and they are able to start flowing, then what happens is light is emitted. That's the light point at which light is going to start being emitted. And essentially, the diode is allowing the current to flow. Now, that is a really important feature. Now, another important feature is not so much of the graph itself, but of the axes that we're looking at here. Interestingly enough, these deal in milliamps. They don't deal in amps because you don't need a huge amount of current or a huge amount of voltage to get these things to turn on. So as a result, you're talking very small threshold PDs. You could be talking something in the realms of maybe 0.2 volts to get this thing to actually turn on. Which is really nice, because if you've ever seen an LED, LEDs are really, really bright. They're either on or they're off. And the nice thing in this case is that you need much less energy to power a LED than you would per se like a filament lamp, which might take 6, 7, 8, 9, 12 volts to get going and actually produce a decent amount of light. So in this case, what we've got here is we've got a threshold PD which allows the electricity to flow through the diode. If it's a light emitting diode, then a light will be emitted. Please bear in mind, all diodes look exactly the same. The only difference between an LED and a diode is the fact that light is emitted at this point where the threshold PD is, which actually gives you a nice indication of when the diode is starting to allow current to flow. So a very nice feature of LEDs. So what do you notice about this line? Well, we've already said it's a non-ohmic resistor. So what we've got here is we've got a situation where the resistance is doing what? Well, the resistance is decreasing. Okay? It initially decreases because here, what is the resistance? Well, if it's got no current flowing, if you don't allow any current to flow, it has to have the maximum possible resistance. Well, what is the maximum possible resistance? Yeah, infinity. Okay, so that's infinite resistance. Up to the threshold PD, you have infinite resistance. When we pass the threshold potential difference, we then start to decrease, and slowly but surely, we eventually taper off. So we've got a situation here where this feature is very, very important to remember. The same with this one, and the fact that it requires very, very little voltage and current to actually get working. So that's an LED. We're going to actually do these graphs and hopefully show these relationships in class. Obviously have a look at them in your textbook. Have a go at a few questions surrounding these, and we'll deal with any issues and problems you have when in class.